Good evening, everyone. My name is Benjamin Gansa, and I'm recording this video as part of the Spatial Data Structures Assignment 1. And then the topic is KD3 for US major cities. So in this project, what I did was to implement a 4D tree to index and then query city level geospatial and then demographic data. And then I implemented this in Python, the notebook to be specific. And what KD tree does is allow efficient querying in multiple dimensional space. And in this data, in this study, we were given um, KD, the Excel file which contains the latitude, longitude, name, and population of cities, and the data also contained a column where of the ID. However, that column was not used in the analysis. So the main objective was to construct a 4D tree from these city records and then also to determine the theoretical height and minimal height of the tree and also to perform progressive refined range queries using spatial and then attribute filters. So for the step, what I did was to load in the data set and then prepare the data set and as part of the preparation, including converting creating tuples for the data set. And as I mentioned, main the data set contains the latitude, longitude, the city name, and then the population. So what I did was first to construct that's the tree construction, and then the first part that I did was to define a KD node using by using the function, and I went to construct another function as part of the tree construction. So that function is the construct tree, which recursively build a balanced KD tree from the city records. So as the requirement for the question one, what it requires also was to do a tree height evaluation, and then the tree height evaluation is to calculate the height using the recursive function and also compute the minimum theoretical minimum height of the tree. The second part of the question required some queries. Okay, some queries, and then I implemented two functions for the querying. That's is within bounds. Okay, that's a valid logical query, and then I implemented the within bounds. And what the within bounds does is to check if a city falls within a given range. Okay, if a city falls within a given range. So I had the upper bound, the lower bound, and if a city falls within this upper and the lower bounds. And then I also had the filter within range. And what it does is recursively search the tree and then collect cities that match the range within the criteria that was searched. So these two functions, the it's within bounds and then the filter within range support the spatial filtering. So it filters the latitude and longitude and then the name and then the population using all the four dimensions as required. And it also did a special builder, okay, that's related to the question two. And then the builders, uh, what it does is to find the bills based on the bounds only. And then the second question related to bounds plus city name that ranges between a particular from C to H to be specific. And then the third one is it does the spatial, that's the X and Y, the name, and then the specified population. And I use the bounds to do the query. As so the bounds was the function that I showed above, and then this does the respective query. And then you can see the respective query that I did here for the question 3 is checking population between 50,000 and then 500,000. And then the for question 2 is checking city with C from C to H. Okay. And then while the first question is only the coordinates, that the latitude and longitude. So for the result of the height, the actual height was 12, and then the theoretical height was also 12, the minimum height. Okay. And then this shows that the constructed tree is optimally balanced and then achieving the theoretical minimum height. And it also indicates that the minimum space strategy effectively distributed the nodes. Okay. Now with the spatial bounds only, we found out that so many of the data sets of the cities fall within, that's using the latitude and then the longitude, and a total of 113 cities fall within or matched the query that I did. The second query had to do with the spatial bounds plus the city name, which starts from C to H. And then in total, I got 34 cities that matched. And then the third query, that's the spatial, that's the latitude and longitude, plus the name plus population between 50 and then 500,000. And in total, I got 6 cities matching this. And these cities included College Station and then Corpus Christi. So in the end, the study demonstrated the use of the KD. In this particular instance, the D was 4. Okay, so we had 4-dimensional tree structure, which allowed for efficient spatial and then attribute-based querying. And I was able to implement this tree from scratch and then validate it, balance, and perform the range queries that I did with high precision all within the Python software. Okay. I also want to declare that I use ChatGPT in this work in refining the codes, generating and then finding the codes, and then my grammatical accuracy in related to the report that I wrote. Nonetheless, I will have to iterate that for every code or every code that I got from ChatGPT, I reviewed it for it and edited it for its relevance. Thank you.